Good morning. Today we are starting our last unit in Math 6, getting ready to move on into algebra, pre-algebra next year. So we are working on a unit that has to do with probability. So this is something that we will revisit again in pre-algebra, but it's good to give us this introduction into it. So we are starting with CO72. I can determine the number of possible outcomes of an event. So this is that beginning introduction. So we need to know what possible outcomes means. Possible outcomes are a list of all the resulting possibilities from an event. So we have to think, well, talking about an event, what does an event mean? It could be like rolling a dice. That is event. I rolled the dice. How many possible outcomes would I have from rolling a regular dice? 6. Why 6? There's 6 sides, 6 different numbers on it. So there would be 6 possible outcomes from that one event. Flipping a coin. How many possible outcomes would there be? 2. You could land on heads, you could land on tails. One event, I flip my coin, and I have 2 possible outcomes. It's really easy when we look at one event, but we're going to look at multiple events that are happening. How many possible outcomes would there be? It's easy to look at that dice and say there's 6 sides, 6 possible outcomes. My coin, I flip it, 2 sides, 2 possible outcomes. Cameron, come move up front here, please. Madison, move over here. All right, so now we're going to look at not just one event, Connor. So one.
Like a cube has like 6, and a coin has 2, is there one that has 1?
That I don't know. I would have to think about that question. It's a good question to ask. So let's look at if we have 3 events. So look at our question. You flip a coin 3 times. How many possible outcomes are there? What are my 3 events? Ooh, why is this not turning how I want it to? Okay, what are our 3 events? Zelda?
The coin, flipping the coin 3 times.
Yeah, I've got flip 1, flip 2, and flip 3. I'm flipping that coin 3 times. There are 3 events. Each time I flip the coin is a new event. So that first time I flip my coin, you know what, I'm going to give myself a little more room. My last thing is going to be my outcomes, and we're going to get to that. So, what are my possible outcomes when I flip my coin that first time? Connor? Yep. Heads or tails. So I start right here, and I have 2 possible outcomes. I have heads, and I have tails. So now I flip that coin again. So my first flip, if I got heads, what are the possible outcomes for my second flip?
Heads or tails?
Heads or tails. So from this heads, I have heads and tails. If I flipped tails the first time, what are the possible outcomes for the second flip? Heads and tails. Now I'm going to flip it a third time. So if I flipped heads and then I flipped heads, what are my possible outcomes for my third flip? Heads or tails? I'm going to do heads and tails. Same thing if I had flipped heads then tails, I could flip heads or tails. Same thing for tails then heads, I could flip heads or tails. Same thing if I had flipped tails, tails, I could flip heads or tails. So heads or tails for my first flip. Then I go to my second flip. If I flipped heads that first time, I could flip heads or tails. If I had flipped tails that first time, I could flip heads or tails the second time. So we're just following each path, saying, okay, if I flipped heads, heads, then what could I get? If I flipped heads, tails, what could I get? If I flipped tails, heads, what could I get? And I flipped tails, tails, what could I get? So then I have my possible outcomes, and I'm going to look at them going through. I could have heads, heads, heads. I could have heads, heads, tails. I could have heads, tails, heads. I could have heads, tails, tails. Now I have all my tails outcomes. Tails, heads, heads. Tails, heads, tails. Tails, tails, heads. Tails, tails, tails. How many possible outcomes was that altogether for my three events? 1, 2, 3, 4, 5, 6, 7, 8. So there were 8 possible outcomes for flipping a coin 3 times. So this is called the probability tree. We're going to do another probability tree, and then we're going to look at the counting principle, because there's always easier ways to do things. But we want to understand what is happening, because sometimes somebody might say, what is the chance that we would get tails, heads, heads? And we need to be able to break it down and say, ooh, there is only one outcome that's tails, heads, heads. Ava.
Well, actually, it wouldn't really be correct, but couldn't you just do 3 times, or 2 times 3? But then, I
2
don't
times
know.
3 is 6. I like what you're thinking. We will look at the counting principle, but I want to do one more probability tree first. Thinking about how we did that probability tree for our coin toss, let's look at what the probability tree would look like if we had 3 pairs of pants and 4 shirts. How many events do we have? If we want to know how many outfits we can make out of 3 pants and 4 shirts, knowing that we're just wearing 1 pants and 1 shirt for our outfit, how many events do we have? Zelda. No, it's not 7. I've heard multiple people say 7. Nope. Nope. How many events? So remember, flipping a coin 3 times, I had 3 events. Who said 2? Yes, because I have pants and I have shirts, so I have 2 events. I'm going to pick my pants, I'm going to pick my shirts. So those are the 2 events, pants, shirts, and then we'll go over outcomes. So, I start off with my pants. How many possible outcomes can I get choosing pants? Ava.
2. 3.
I have 3 pairs of pants. So I have 3 possible choices, right? So let's say this was my jeans, my joggers, well, let's call them shorts, because I don't think too many of our boys are going to be wearing leggings. Okay,
Yes, sir.
good, but now how many possible outcomes are there with those shirts? If I pick a pair of jeans, I have 4 shirt choices. So maybe I have a white shirt, a blue shirt, a red shirt, and a green shirt, right? So with my jeans, I could either wear white, I could wear blue, I could wear red, or I could wear green. Now I'm putting on joggers. How many shirt outcomes are there? 4. So with the joggers, I could wear white, I could wear blue, I could wear red, I could wear green. Same thing with my shorts. I could wear white, I could wear red, I could wear green, I could wear blue. I put it in a different order, it's the same colors. So let's look at how many outcomes that is. I could do jeans with a white shirt, jeans with a blue shirt, jeans with a red shirt, jeans with a green shirt. I could do joggers with a white shirt, joggers with a blue shirt, joggers with a red shirt, joggers with a green shirt. I could do shorts with a white shirt, shorts with a blue shirt, shorts with a red shirt, shorts with that green shirt. How many possible outcomes are there when I have 3 pants and 4 shirts? 12. If I add them all up, I see I had 12. Just like with my probability tree, I added up all of those possibilities of flipping heads and tails, and I had 8. Yes.
I can't see.
Okay, go sit back by Jimena and Madeline. All right, so some of us were saying, hey, it's a lot of work we have to go through. Those probability trees, whew, sometimes it is important, Connor, your attention's still up front. Sometimes it's important that we know the different actual combinations. A lot of times we just want to know how many. I don't care that it could be jeans and a blue shirt, jeans and a red shirt, jeans and a green shirt. Because if the question's not asking for it, if it's just asking how many possible outcomes, how many outcomes are there if I'm flipping that coin 3 times, we're just going to use the counting principle. Because Marina's absolutely correct. There is an easier way to do it. So when we look at the counting principle, we're going to put on top, we're going to put how many events, which events are happening. So what do you think I should write on top? What did we talk about with the events with those coins, Zelda?
The events.
What are they?
There's heads and tails.
The flips. Remember, we had event 1 was flip 1, event 2 is flip 2, and event 3 is flip 3. On the side, we're going to write number of outcomes for each event. So when we were flipping that coin the first time, how many outcomes did we have? We flip a coin 1 time. 2, heads or tails. So I'm going to put a 2 under flip 1. How many possible outcomes do we have for flipping a coin? That second time, I still have 2, heads or tails. How many possible outcomes are there for flipping our coin that third time? 2, heads or tails. Right? Now, somebody was thinking ahead and saying, well, But if we multiply that 2 times 3, that's not quite right. We have to look at our events and how many possible outcomes there are for each event. And then we multiply. We multiply all those outcomes together. What's 2 times 2?
4.
What's 4 times 2?
8.
So you don't just say, well, I'm flipping the coin 3 times, and there's 2 outcomes, so it's 6. No, you have to do every single event. Event 1 had 2 outcomes, event 2 had 2 outcomes, event 3 had 2 outcomes. Then you multiply all of those outcomes together. Connor.
On the bottom, you multiply 4 times 3 to get 12.
Because how many events are there for our outfits? There's pants and there's shirts. Right, and then we have our outcomes for each. So you're right, pants has 3, shirts has 4. When it's only 2 outcomes, when it's only 2 events, you just multiply those 2 together. When it becomes tricky is when we have more than 2 events happening. Because Connor is right, 3 times 4 gives us those 12 outcomes. You have to list every event. And this isn't me just giving us extra work, show your work, show your work, show your work. No, you have to list every event. You have to say, okay, I'm going to choose pants. Now I'm choosing shirts. How many outcomes are there for each thing? Because what if we had socks and we had shoes to go along with those outfits? We would have more events that we need to put in there, more numbers to multiply. Does that make sense?
Yeah.
All right, so let's move this up. Using either method, determine the possible number of outcomes. Show your work. And we're not just saying show your work because we want you to do busy work. You truly need to list every event and the outcomes that go under it. I personally like the counting principle because it's easier. It's less writing. So let's try it with the counting principle. You flip a coin twice and roll a 6-sided die. How many possible outcomes are there? So the first thing we have to determine is how many events there are. How many events do we have? Show me with your fingers.
Just many.
I see a lot of 2 fingers up, and I see Melanie has 3. Melanie, why do you have 3 fingers up?
Two times you flip the coin and then 1 time you roll the dice.
We flip a coin, flip 1, then we have to flip it that second time. Flip 2, then we roll the dice. So you are absolutely correct, Melanie. There are 3 events happening. We flip that coin twice, that's 2 events. Then we need to put how many outcomes for each event. Flipping a coin, how many outcomes are there?
2.
2, heads or tails. We flip a coin, how many outcomes are there? 2, heads or tails. We roll a 6-sided die, how many outcomes? 6, there are 6 numbers. What do I do next? I have to multiply across. What is 2 times 2?
4.
What is 4 times 6?
24.
There are 24 possible outcomes. So you have to be very, very careful that you are finding every event that is happening. If it says flip a coin twice, that's 2 events that you are doing. So we have to be extremely careful making sure we're getting all the events. So let's look at our next page. So using either method, if you want to use the probability tree, you can. Absolutely nothing wrong with that. Sometimes when we forget how to do it, we just need to list every combination. It's a valid way of doing it. Counting principle is just quicker. So I like to show it with the counting principle, but if you want me to go through and show the probability tree, I can. Let's do this first one together. A pizzeria. So everybody put your pencils down. Pencils down. A pizzeria has 4 types of crust, 15 toppings, and 5 pizza slices. How many one-topping pizzas can be ordered? Show me, pencils down. Show me with your fingers how many events are happening. Sawyer, why do you have 3 fingers up?
Because it says, it says 4 types of crust, 15 toppings, 5, and that's 3.
Yeah, we've got crust, we've got toppings, and we have sizes. So there's 3 different events happening. Crust, toppings, sizes. So that's what I'm going to label. Crust, toppings, and sizes. Now I need to know how many outcomes there are for each of those. How many outcomes are there for crust? Amanda. How many outcomes for toppings, Liam?
15.
How many outcomes for sizes? Dom.
5.
What do I do next?
Multiply.
Oh, thank you to my friends who are raising their hand. Show me that you know what to do. Raise your hand if you know what to do next. Anna Mae, what do I do?
Multiply.
I multiply across. 4 times 15 times 5 gets me 300. I want to see every event that's happening. I want to see how many outcomes go under each event. And then you multiply it across. So you must show your work. I want it labeled. I don't want you just putting numbers down. I want you labeling what each event is. Why do you think I'm making you label every event? Marina?
So,
Yeah. It is important that we label it so we make sure when we look back at the question, did I answer it correctly? Did I get every event? If it says you're flipping that coin twice, did I list it 2 times? 2 events. Okay, so it's your way of double checking your work to make sure you're not missing any events. Because I promise you, I have taught this class for a few years now. I've taught the pre-algebra class. I have to teach them about probability. There are always people that miss events. So they don't have that outcome to multiply through and they get the wrong answer. Label your events so you can put the outcomes under each event and you don't make those simple mistakes. Any questions? Okay, so remember, you are working on missing con. If you have past due assignments, check Blackbaud. Even if they were from April, math builds on itself. We have not moved on and we're done with those objectives. We still need to learn them because we will build on them and see them in the future. So if you have past due con assignments, you still need to do them. Don't just accept the 0 or the low number. Email me when you have them done so I can check them. Packet number 11, I still have missing from people. Turn in your packet 11s. I will still accept those. Packet number 12 is due next week, Friday. If you met your math test goal, it is extra credit. Turn it in, get those extra points. That always helps. I have it listed in Blackbaud in two ways. One says math packet number 12, and one says math packet number 12 extra credit. You are excused from the one that doesn't apply to you. So if it's extra credit, you're excused from the regular packet number 12. And if you have to turn in packet 12 as an assignment, then you're excused from the extra credit. Lilia.
Well, if you have it for extra credit, do you have to finish all of it?
No. If you have it as extra credit, you can choose not to turn it in at all, and you'll get 0 extra credit points. It doesn't hurt you. You can choose to do the whole thing and get 10 points. You can choose just to do a few pages and get a few extra credit points. Okay. Any other questions about packet number 12? If you have it as your assignment, because you didn't make that map a goal, you must do the whole thing or it will hurt you. All right, if you are watching this at home, I hope you are well and I hope to see you soon. Have a wonderful day.